How are you, everybody? I hope you are doing well. I am coming with the next topic of this chapter, that is an infinite series. Let us start. Infinite series. Given that the an start from m to infinity is a sequence with terms a1, a2, a3, then the expression a1 plus a2 plus a3 plus that can be written as the sum of an when n starts from 1 to infinity is called an infinite series. So an infinite series is the sum of all terms of the sequence. Finite terms S1 that is equal to A1, S2 that is equal to the sum of the first two terms of the sequence that is equal to A1 plus A2, S3 that is equal to A1 plus A2 plus A3, and Sn that is equal to A1 plus A2 plus A3 plus An are called the partial sum of the infinite series, are called the partial sum of the infinite series n start from 1 to infinity. Here, as you can observe, the partial sums in turn forms a sequence whose terms are a partial sum that is equal to Sn when n starts from 1 to infinity is called the sequence of partial sum. A partial sum by itself forms an infinite sequence. As an example, if an is equal to 1 over n from 1 to infinity is a sequence, the expression that is the sum of 1 over n when n is from 1 to infinity, that is equal to 1 plus 1 over 2 plus 1 over 3 plus is an infinite series. Next, let's take an is if 1 over n into n plus 1 when n from 1 to infinity is a sequence that is equal to 1 over n minus 1 over n plus 1 n from 1 to infinity is a sequence. Then S1 that is the first partial sum of the sequence is equal to 1 over 1 minus 1 over 1 plus 1 is equal to 1 minus 1 over 2. S2 is 1 minus 1 over 2 plus 1 over 2 minus 1 over 3. S3 is equal to 1 minus 1 over 2 A1 that is A1 plus 1 over 2 minus 1 over 3 that is A2 plus 1 over 3 minus 1 over 4 that is A3. Therefore, continuing in a like manner, generally Sn is equal to 1 minus 1 over n plus 1. 1 minus, as you can observe, 1 minus 1 over n plus 1. So Sn is this one. And those are partial sums. And the sum of 1 over n into n plus 1 when n is from 1 to infinity is an infinite series. And a sequence a sequence Sn that is equal to 1 minus 1 over n plus 1 when n from 1 to infinity is called a sequence of partial sum. For the series sum of 1 over n into n plus 1, n into 1 over n into n plus 1 when n is from 1 to infinity. So this one is all about what an infinite series is. The next one that we study is convergence of an infinite series. Let me describe the convergence of the infinite series. Let Sn n from 1 to infinity be a sequence of partial sum of an infinite series. The sum of n from 1 to infinity. Then the series n from 1 to infinity converges to S. Converges to S if the limit of Sn as n goes to infinity is equals to a number S. If and only if the limit of Sn as n goes to infinity is equal to a number S, we say that the infinite series An converges to S. And the sequence n from 1 to infinity diverges if the sequence Sn n from 1 to infinity diverges. If sequence of partial sum diverges, then the series, the infinite series diverges. So the number to weights the value of the series. So we can say that the value of the series n from 1 to infinity is the number to which Sn converges. The number to which Sn n from 1 to infinity converges is the value of the series. Let us take the example whether the following series converges or diverges. For this that are convergent, determine their value. Determine their value. One, the sum n from 1 to infinity, say 1 over n into n plus 1. B, the sum n from 1 to infinity, say 1. C, the sum n from 1 to infinity minus 1 the power of n. D, the sum n from 1 to infinity, let's say to the power of n. E, the sum of 1 over to the power of n from 1 to infinity. Now let us determine the convergence of those series, if say the sum n from 1 to infinity of 1 over n 1 over n. Now let us see the convergence of this series. Let us see the first one. As we have tried to see here, S1, the first for the sequences for 1 over n into n plus 1, for this sequence, the partial sum S1 is equal to 1 minus 1 over 2. 1 minus 1 over 2. S2 is equal to 1 minus 1 over 2 plus 1 over 2 minus 1 over 3. S4 is equal to S3 is equal to 1 minus 1 over 2 plus 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4 minus 4. So, as it can be observed, Sn for all n, Sn is equals to 1 minus 1 over n plus 1. 1 over n plus 1. Thus, limit of Sn as n goes to infinity is equal to the limit of 1 minus 1 over n plus 1 over n plus 1 as n goes to infinity. As n goes to infinity, n plus 1 goes to infinity. So 1 over n plus 1 goes to 0. So Sn, limit of Sn is equal to 1 minus 0. That is equal to 1. That is equal to 1. This implies a sequence of partial sum Sn when n starts from 1 to infinity, that is equal to 1 minus 1 over n plus 1 when n from 1 to infinity converges to 1. Converges to 1. Thus, the sum of 1 over n into n plus 1 when n from 1 to infinity converges to 1. Converges to 1. Converges to 1. As n goes to infinity, the value of this series is equal to 1. Since the sequence of partial sum converges to 1. Sequence of partial sum converges to 1. Next, let us see the sequence given in B. The sequence given in B. Given in B. For this series, the sum of 1 n start from 1 to infinity. The first term of this series is 1. So S1 is equal to 1. S2 is equal to 1 plus 1. That's equal to 2. S3 is equal to 1 plus 1 plus 1. That's equal to 3. That implies Sn is equal to A. Sn is equal to A. Thus, the limit of Sn as n goes to infinity is equal to the limit of n as n goes to infinity, that is equal to positive infinity. Positive infinity. This implies a sequence of partial sum Sn n from 1 to infinity, that equal to n from 1 to infinity is divergent. This implies the sum of n from 1 to infinity is divergent. This sum goes to infinity as n goes to infinity. This sum goes to infinity as n goes to infinity. N goes to infinity. For a sequence, the sum of minus 1 the power of n when n start from 1 to infinity. For this sequence, what will be S1? Minus 1 the power of 1. Minus 1. S2 is equal to minus 1 the power of 1 plus minus 1 the power of 2 is equal to minus 1 plus 1, that's equal to 0. S3 is equal to A1 plus A2 plus A3, that's equal to minus 1 plus 1 plus minus 1, that's equal to minus 1. And Sn is equal to 0 if n is even, and minus 1 if n is odd. And when n is odd, Sn is equal to minus 1. When n is even, Sn is equal to 0. So a sequence of partial sum is divergent. This implies Sn is divergent. Thus, Sn is equal to minus 1, 0, 1, minus 1, 0, minus 1, 0, and continue. Therefore, Sn, a sequence Sn, and from 1 to infinity, is divergent sequence. This implies the sum of minus 1 the power of n when n start from 1 to infinity is divergent series, is a divergent series. Next, let us see the sequence given in D. For the series, the sum of 2 the power of n when n is from 1 to infinity. What is S1? When n is from 1 to infinity. When n is equal to 1, it is 2 is equal. For this one, Sn is equal to 2 plus to the power of 1 plus to the power of 2 plus to the power of 3 plus to the power of n plus to the power of n. This term is greater than to the power of n, isn't it? Sn is greater than to the power of n. So, evidently, limit of Sn as n goes to infinity is equal to, is greater than the limit of to the power of n as n goes to infinity, is equal to the limit of to the power of n as n goes to infinity, that is equal to positive infinity. Therefore, since the sequence of partial sum Sn is divergent, the infinite series is divergent. So, those since Sn is divergent, the sum of to the power of n and from 1 to infinity is divergent, is a divergent sequence. For the fifth one, for the series, the sum n start from 1 over 2 the power of n when n start from 1 to infinity. For this series, Sn is equals to 1 over 2. For this one, Sn is equal to 1 over 2 the power of 1, that is 1 over 2, plus 1 over 2 the power of 2, plus 1 over 2 the power of 3, plus up to 1 over 2 the power of n plus 1 over 2 the power of n to the power of n. Multiply both sides of this by 2. Multiply this by 2. It is simply to write the general formula for Sn. If we multiply both sides by 2 times Sn, this implies 2 times Sn is equals to 2 times 1 over 2, 1 plus 2 times this 1 over 2 plus this times 2 1 over 2 the power of 2 1 over 2 the power of 2 plus 1 over 2 the power of 3 plus 1 over 2 the power of n times 2 1 over 2 the power of n minus 1 to the power of n minus 1 is equal to 1 over 2 1 plus 1 over 2 plus 1 over 2 square plus 1 over 2 the power of 3 plus 1 over 2 the power of n minus 1 plus 1 over 2 the power of n minus 1 over 2 the power of n. We can make this one. But the sum from 1 over 2 up to 1 over 2 the power of n is what is this one? Sn is Sn. This one is Sn. Therefore, 2 times Sn is equal to 1 plus Sn minus 1 over 2 the power of n. So, subtract Sn from both sides. This implies S2Sn minus Sn is Sn is equal to 1 minus 1 over 2 the power of n. 1 over 2 the power of n. Now, compute the limit of Sn as n goes to infinity. Now, the limit of Sn as n goes to infinity is equal to the limit of 1 minus 1 over 2 the power of n as n goes to infinity. That's equal to 1. That is equal to 1. That is equal to 1. Therefore, evidently Sn n from 1 to infinity, that is equal to 1 minus 1 over 2 the power of n from 1 to infinity, and hence the sum of 1 over 2 the power of n when n starts from 1 to infinity converges to 1. Converges to 1. Converges to 1. This one is all about the infinite series and its convergency, and also how to determine the convergency of the infinite series.